All right, so now we've done means, we're going to look at percentiles. So percentile is saying what value of my x will result in a certain percentage being less than that. So if I said what's the 10th percentile, I'm saying what value of my x will result in 10% of my random distribution falling in that. Or I could ask for a 70%, so it'd be somewhere up here, because that would be 70% of their total area. 90% would be up here. So what I want to do is find what value of x gives me a percent that I'm looking for below this. So here, what I really want is this to be my unknown. So when I put this into my equation, I'm still going to minus infinity, although you could do a percentile in the other direction. You could say 50% of my values are higher, or 90% of my values are higher, in which case you'd swap these around. And this x, I'm going to say, is a. So I'm saying going from all the way from 0 to that point of my f of x, and I want to equal my percentile that I'm looking for. Now, if I'm looking for my median, well, my median, by definition, maybe I could use m there, is halfway through my population. So that my percentile would be 50th percentile, and I write that as a decimal in all these cases. So I want to find my A, or I could use an M maybe, that will make this equal to 0.5. So let's look at the example. I've got durations of a call in a particular call center are given by this. So this is the number of minutes it takes. It's a little bit complicated, but we can use this function, and a little just diagram of this. It's an exponential, but it's to a negative power. So it's going to sort of look something like that. So it's saying that there's lots of smaller calls, fewer and fewer bigger calls. In theory, they could last any length of time. So now, I want to know, find the length of time that 90% of the calls are less than. So I want to do, in this case, I don't have to put a minus infinity because I know that it only goes down to 0 of my f of x, which is going to be a third e to the minus x over 3. And I wanted 90% of my calls to be less than, I'm going to put 0.9. So now, integrating this, well, if I remember integration of my e to the ax, then that says that I want to do, let's write my third down, I leave this the same, oops, that's a 3 there, it's a bit hard to write, and then I divide by my a, in this case it would be a minus a third. And I want to go to a to 0 equals 0.9. So now, if I'm dividing by a number, I can flip that number in times. So I can say that's 1/3, and I'm just going to put times minus 3 over 1 e to the minus x over 3. And those all cancel. I just end up with a minus e to the minus x over 3 between a, that's an a, and equals 0.9. Get another piece of paper. And so now putting my values in, I'm going to have minus e to the minus a over 3, and then putting the 0 in, it's going to be minus a negative e to the 0 equals 0.9. Now, e to the 0 is 1, so I've got plus 1 there. Minusing 1 off both sides.